Hello everyone, good evening and welcome to my channel Aptitude Club. This is the second video of the QA Booster series. If you missed out the previous video, I'll pin it in the I section and I'll also provide the link in the description. Do watch it. In this QA Booster series, I'll take up one important question from the Quantitative Aptitude section in every video and we'll see that particular question, the concept involved in it and how do you approach and the thought process behind the question in that video. So if you're new to my channel, and you're watching this for the first time, do explore my channel and the videos, and if you like the content, do subscribe to the Aptitude Club channel because you'll get some content related to your CAT preparation every day on this channel. So without further delay, let us try and discuss this question today. This is the previous ZAT question, okay, and this question belongs to the chapter special equations. Okay, special equations we call it. So I would request all of you to pause at this moment and maybe try out this question first yourself and then look into the explanation how it is solved. Okay, so I'll give you a little context. What are special equations mostly? So what happens is whenever we are solving linear equations, now in linear equations, the number of equations should be greater than equal to the number of variables if this implies you can calculate unique values. Unique values can be calculated. For example, if I have two variables, two equations. If I have three variables, I would need three equations. Four variables, four equations, and so on. But sometimes in questions, what will happen is we'll have two variables but one equation, or three variables, two equations. So in that kind of a situation, ideally it is not possible to uniquely calculate the variables or the number of solutions. It's not possible to uniquely say what is the solution of that particular system of equations. Okay, but sometimes in special equations some extra conditions are given. That is why we call these kind of questions as special equations. You will be given some extra conditions in the question, not equations but some extra conditions, and with the help of these extra conditions you can find out the number of solutions. Okay, it is possible to determine. That is the whole context of special equations, and in CAT exam we have seen a lot of times. This year also in CAT 2022 we had a question in special equations. A lot of times questions have been asked from this area, very simple to solve, but it's an important area in algebra. So let's try and see how do we solve this particular question. Now it is saying Nikhil's mother asks him to buy 100 pieces of sweets worth rupees 100. Now he goes to the shop and three kinds of sweets are there: Kaju Barfi, Gulab Jamun and Sandesh, costing rupees 10, rupees 3 and rupees 0.5 respectively. So I'll take let Nikhil bought X Kaju Barfi and then Y number of Gulab Jamuns and Z number of Sandesh. So we converted it into variables. So I'll get my first equation, that X plus Y plus Z is the total number of sweets bought, that is 100. So this is my equation 1, three variables again. What's the second equation? If I look in terms of money, 10 rupees per Kaju Barfi, so X Kaju Barfi, so price is 10x. 3 rupees for each Gulab Jamun, so 3y. And this is 0.5 rupees or 1 by 2 I can say. So it is Z by 2 rupees. And this is also 100 because he is spending 100 rupees. 100 pieces of sweets worth rupees 100. So I basically got two equations. But now you see this, there are three variables. Two equations, three variables. So we reached at a special equation condition. So what is the condition that is given apart from the equations? Now that condition is not explicitly written in the question, although we have one condition here that he decided to buy at least one sweet of each type. That means X, Y and Z are not equal to 0. I can say definitely greater than 0. I can also conclude that x, y and z are necessarily positive integers, because you don't go to a shop and say I give me let us say 3.5 काजू बर्फी 2.6 गुलाब जामुन, वैसे तो नहीं बोलेंगे. He will buy integer number of sweets, and none of these integers are zero, because he has decided that at least one तो वो खरीदेगा. तो x का minimum value 1, y का minimum value 1, z का minimum value is 1. So this is the extra condition mentioned in the question. So what is it that we are trying to find? How many types of gulab jamuns? That means we are concerned about the variable y. How many gulab jamuns did he buy? Now to solve this, because I want y, I can eliminate any one of the variable x or z, जो भी convenient लगेगा. So I'll do 2 times equation 1. Equation 1 बोलना 2 times equation 2. If I want to eliminate z, 2 times equation 2 minus equation 1. So I get 20x plus 6y plus z is equal to 200, and I'll get x plus y plus z is equal to 100. So just simply subtract and you get 19x plus 5y is equal to 100. This is my third equation, where x and y are positive integers. Now, if you know how to solve from this point, because that's a particular way of solving special equations, and linear equation का एक interesting property comes in that intermediate step. If you know how to solve this, you can easily solve. For those of you who don't know, what we do after this step is basically take this. If I have this equation 19x plus 5y is equal to 100, the first step is divide the least coefficient throughout. Divide the least coefficient throughout, because from this one equation I cannot find the solution. There are infinite solutions. So I'll divide 5 throughout. So 5y divided by 5, I get y. 19x is not divisible by 5. So 15x उससे पहले divisible था. So maybe I'll write it in this way: 15x plus 4x divided by 5. 100 divided by 5 is 20. So I get y plus 3x plus 4x divided by 5 is equal to 20. Now 20 is an integer, y plus 3x is an integer, which tells me that 4x by 5 must be an integer. Or else how come LHS and RHS will be same? If the RHS is an integer, LHS has to be an integer. This implies 4x should be divisible by 5 if it is an integer. Now in 4x, 4 doesn't contribute to the divisibility of 5, so x must be divisible by 5. X should be divisible by 5. Once you know this, to arrive at this result only we did this thing. Because the moment I give you only the equation 19x plus 5y equal to 100, from there figuring out what can be x and what can be y is difficult. So to break it down and bring it to a stage where you can predict or you can understand what can be a possible value of x or a possible value of y, you need to divide the least coefficient throughout, so that you break down the equation, bring it to a structural form where you will get a condition for arriving at the first value of x or y. And all you need is the first value. Why? See this. If x is equal to 5 and x is divisible by 5, so first value 5 लेंगे. X is a positive integer divisible by 5. The smallest possible value is 5, followed by 10, then 15, then 20, then 25, and then I can go on like this till infinity. Now once I've got x, for each possible value of x, I can get a corresponding value of y. For each possible value of x, I'll get a corresponding value of y. And the values will be like this. If you put x is equal to 5 in the equation, so y will be 1. Then if you put x is equal to 10, so y is like minus 18. And for each possible value of x, you can keep doing that, and so on till infinity. Now there comes an interesting pattern here. Look how x is changing. And this is true for all cases. X changes by 5, and this 5 is basically the coefficient of y. This property satisfies for all linear equations, that x will change by the coefficient of y and y will change by the coefficient of x. X changes by the coefficient of y, whereas y changes by the coefficient of x. But one thing is that x, if you are increasing, y will decrease, and vice versa. If you are decreasing x, y will increase. Suppose I go back, I'll decrease x, so this becomes 0. So you increase y, so y will become 20. So look at this, 0 and 20 will also satisfy this equation. So the next value of y, if you are trying to calculate, again you subtract a 19. So minus 18 minus 19, you get minus 37. Then you again subtract a 19. So you get minus 56. Again subtract a 19, you get minus 75, and so on. So keep getting values like that. So that is why all we need is the first value. If I get the first value, then I know how it is going to change. X will change by the coefficient of y, y will change by the coefficient of x. But you have to keep in mind that, okay, in this case, we call this kind of an equation as a bounded equation. So as a result, if x will increase, y will decrease, and vice versa. So I see that, okay, there is only one possible value. Rest in other cases it is not possible. Only one viable option is this, because if I'm going for 10, this is negative. You cannot buy negative number of sweets, so ये सारे cases not possible. And if I'm going back, maybe this is possible, but 0 is not possible again. Nikhil has decided to buy at least one sweet of each type. So I get x is equal to 5 and y is equal to 1, and this is my answer. How many gulab jamuns did he buy? So only one. So although you see mathematically it was indeterminate because I had three variables and two equations, yet I could arrive at the answer because of this special condition. So my answer is this, option 1. Okay, Nikhil bought only one gulab jamun, and that's the only possibility. यहाँ पे और कोई possibility नहीं हो सकती. I hope all of you got an idea how to solve questions in special equations. This property, the change in x and change in y, it always holds true. You can explore more questions on this category, and very important topic as far as CAT is concerned. You do get regular questions from this area. So hope all of you understood this question. That was it from my end for this video. If you have watched it this far, I hope you understood the solution and got the context of special equations. Do subscribe to my channel for more such content on CAT and quantitative aptitude preparation. We'll meet again very soon on yet another video. Till then, keep solving, keep studying. Thanks for watching, and have a nice day. Bye bye.